Hey, we're recording now.
Okay. Max, do you have paper?
Yes.
Oh, it has Stefan. Okay. All right. Great. Okay, so today, before we get started talking more about quadratic equations and parabolas, let's go ahead and review what we talked about yesterday. So if we have an equation of the form y equals ax squared, it's going to be a parabola like this. You can ignore this cross section for now. So yes, it's going to be a parabola like this. If a is positive, does that ring a bell? Right? So if the number that's in front of the x squared is negative, then this would be like that, right? Is that all tracking from yesterday? Okay, I see nods. That's a good sign. Okay. Today, and the vertex, so the highest point if it's downward facing, or the lowest point if it's upward facing, is going to be 0, 0 for this form. Whenever it's in that form, the vertex is 0, 0. But today we want to try something a little bit different to build on this from yesterday. So today we want to ask ourselves, what happens when we have y? So if we actually know what y is, so then we're trying to solve for x instead. So that's where we get a situation like this. So here, let's say y equaled, I don't know, let's say y equals, 3, or whatever this number is here. So if y equals 3, then we can represent this graphically with this cross section. And you'll see that for that one y value, we have 2 x values. So that means there's going to be 2 solutions. So to think about that, more generally speaking, if we have an equation of the form b, so this b here means some amount. So if that equals ax squared, then we kind of can translate that into, so we would have b divided by a equals x squared. Is that tracking for everybody? Okay, and then x would just equal plus minus the square root of b over a. So we have to have that plus minus here, right? Because just like over here, we have 2 values of x for each value of y. We could have a similar thing down here if it was the other direction. So if this was negative. Okay. So let's try an example. Okay, so b equals a. Alright, so let's try this. So let's solve 3x squared equals 39. Okay, so what's going to be the first step in solving this equation?
Squaring it. Would we divide 3 on both sides?
We would divide each side by 3, right? So this is the same as times 3, right? So if we divide this by 3, and we divide this by 3, then we'll get x squared equals, anyone know what that equals?
13.
Yep, it's 13. Okay, so now if we want to find x, which would be our last step, what's x going to equal?
With the square to 13.
Okay, so this equals x squared. This equals 13.
So square root of 13.
Yeah. So x equals the square root of 13. And what are we missing?
Plus minus.
Yeah, that's it. Yeah, so plus minus 13. Yep. Okay, now we're going to have another example. This one is going to use height. So the idea is that if we drop a quarter, let's say, off of a building, we have an equation that tells us the distance. Well, okay, let me rephrase this. So we have some distance, so that's d, and that equals 16 times time squared. So this is going to be, I believe, in seconds. Yeah. Okay, so this is in seconds. Okay, and then since we are solving, or since we know, in this case, we're trying to find the time, and we know the distance. So the distance that we have is 64. So this equals 64. So we just basically have 64 equals, so it's going to be 16 t squared. So this is still following our same kind of format that we've been using here. So if we know the distance is 64 feet, and we know this is our equation to get that, then we're just solving for the time in seconds. So what would be the first step here to solve for the time in seconds?
Divided 16 on both sides.
Exactly, yeah. Divide this by 16, divide this by 16. So that's going to equal, what's 64 divided by 16?
4.
Yep. So 4 equals t squared. Okay, so what is t going to equal? Grace?
Square root.
The square root of 4?
Plus
Okay.
minus. Yeah.
Ah! Yes. So that's one of the helpful things about this example. So yes. So if we have t equals the square root of 4, which is 2. So in this case, t is actually only positive because we don't have negative time. So you want to watch that. So if you have a specific equation like this, sometimes the answer won't always be plus minus, just because we're only looking at one side of it for this. Okay, now we'll try a little one that's a little different. So now we're gonna complicate things. See if we're still tracking. So we want to solve. So solve. Okay, so this is still a similar kind of format. Anyone have an idea of what probably the first step would be to solve this?
Would it be squaring on -12?
No. So think about if we have, so I guess this would kind of be right? That makes sense? So this is the form. This is our standard form.
So you have
So we know what B is, right? We know what A is, and this is x squared.
What is A?
What is a? Yeah, what is a?
3.
Yes, and what is x?
N minus 12.
Yes, and of course 75 is b. Okay, so think about how did we approach solving the other ones? Think about that, and how do you think we would approach this one?
Divide 3 by 75.
Or divide the 75 by 3?
Yeah.
Yeah, divide the 75 by 3, yep. Yeah, so if we go ahead and then divide this by 3, divide this by 3, so that'll be n minus 12 squared equals, and that's going to be 25. Okay. Okay, so then where would we go from here?
How do we find the square root of 25?
Yep. So we're gonna this will give what it'll happen. So what would be? So we'd have the square root of 25 here, and it would be plus minus. And then what would we have here?
Wait, why didn't we divide n by 3 and negative 12 by 3?
So this is like a 3 times here.
Uh-huh.
So we're just canceling,
Oh, okay.
right? And then over here we're dividing by 3. Okay, so what would go here? So we have so this is effectively like our x squared, right? And then we have our b over here. Or our b divided by 3, yeah. So what would be here is just n minus 12. Does that make sense? So we
That's
start.
the final answer?
No.
Okay.
No. Okay, so now we keep going. So we have n minus 12 equals, so we'll start with positive 5. Plus 5. We have to solve it twice, right? Because there's 2 answers.
Wait.
So now we can add 12 here. So then n equals 17. That's the first answer. Wait, did I do something wrong?
Oh, sorry.
Oh, no, it is right. I did it different. I wrote it down different from my example. Oops. Okay.
That's solution 1.
Yep, this is solution 1. And then for solution 2, right, we're going to have n minus 12 equals, in this case it's going to be negative 5, right? So then we're going to add 12 to each side. So then we're going to have n equals, it's going to be positive 7. Does that make sense? Okay. Okay.
And that's just because x has 2 answers.
Right. So yeah, so like where we talked about before, I'm trying to think here what this would look like.
It moves
It's going to be
it
positive.
moves it down 12 on the axis.
Yeah. Okay.
So just draw an axis, I'll show you. So,
Okay.
so that negative 12 there is actually going to move the parabola, which this is kind of beyond you right now. It's going to move it down 12 on the y-axis. So if you showed the picture there, move it down 12. Oh, actually, no, it's not. It's going to move it to the right 12 on the axis.
Okay.
So it would go over 12.
Here.
Yeah.
And then it would just open up, right?
Yes, it would open up. And so if you look where x is 25, or y is 25, which is in a sense what you have there, or y is 25,
Right.
or
So
75, either one.
so somewhere up here.
And so it's gonna, notice that 17 and 7, looking at your picture there, 17 and 7 are equal distance away from that 12. So if you go 5 away from 12, you get 17, you go 5 the other way from 12, you get 7. That's where those points are gonna be equal to each other up there. And so so kind of draw down so they can see that. From the points where they intersect, just draw down.
Right here.
Yeah, draw down, straight down. So if you look at those, they are gonna be, there's 12, so you go subtract 5, and add 5, and that gives you the 2 points that will be equal to that. So that's why you have to have 2 answers, because of that, okay? So kind of like he showed you on the original one, this is a little bit different one, because we haven't talked about how that graph looks, but it's very much the same. On a quadratic, you're always gonna have 2 answers. You're always gonna have the positive and the negative answer, because there's 2 spots that go through that same y.
Unless you're solving for something that has to have a positive.
Unless you
answer.
have to have a positive, yes.
Okay, let's see here.
Oh, yeah. Right, okay.
Okay, organize yourselves into groups.
Wait,
What?
So,
Max, I want you.
Yeah, you should come out.
I wanna be with Max.
oh, well. Let's see, it's $5 if you want me in your group, guys.